Hello students. Now we will be learning about carbylamine test and Heinsberg test, two very important reactions. Let's start with the first, that is Hofmann's carbylamine test, also referred as isocyanide test. Now, aliphatic or aromatic primary amines, when reacted with chloroform and alcoholic KOH, gives alkyl isocyanide. Let's see how the reaction occurs. Let's take a primary amine. To this, we would add chloroform, that is CHCl3, and to this, we are adding 3 molecules of KOH. Now, what I would do is 3 molecules of KOH, I would write it something like this. Now, what happens? Let's check out. All the 3K combine with the 3 chlorine atoms, giving us 3 molecules of KCl. Also, 2 hydrogens from primary amine and 1 hydrogen from chloroform combines together with the 3 OH groups, giving us 3 water molecules. So finally, what we are remaining with is nothing but our single bond N and triple bond C, that is nothing but isocyanide, and this isocyanide is called as alkyl isocyanide or a carbylamine. Now, a very important point, this reaction is only and only possible with primary amines and not with secondary and tertiary amines. So definitely this would be a distinguishing reaction between primary and secondary tertiary amines. Let's move further. Now, what we can say is, let's take an example. Let's have an ethylamine molecule. This ethylamine molecule was treated with chloroform. So what you got? In the presence of 3 KOH molecules, the first compound which we are getting is C2H5NC, and lastly we are getting 3 KCl and 3 H2O molecules. So what we all need to remember over here is that ethyl isocyanide was produced. Yes, but a very important fact was that the number of carbon atom was increasing. Means if the primary amine was having 2 carbon atoms, then the product was total having 3 carbon atoms, and NH2 group got converted into a N triple bond C group, that is a isocyanide group. Now, this was all about carbylamine test. Let's move further with the reaction of amines with aryl sulfonyl chloride, also referred as Heinsberg test, a very important reaction once again. Let's start with this. Now, first of all, as Heinsberg test says, it is a distinguishing test for amines. What we are using in this, let's see. Heinsberg test is required, or Heinsberg test is performed using an agent called as aryl sulfonyl chloride, that is benzene sulfonyl chloride, because aryl groups are also referred as benzene. Now, what we would do with this Heinsberg reagent, let's see. We would take a primary amine, treat it with Heinsberg reagent, that is benzene ring attached to S, double bond O on both sides and Cl. So now what would happen? H from the primary amine would combine with Cl, giving us HCl. And also with this, what you would get? You would get a compound, that is RNH combining with that sulfonyl group. And because of this, what would be the final compound that would be obtained? Would be nothing but a sulfonyl group, which is an electron withdrawing group, attached to a acidic hydrogen. And right now the name of this compound would be benzene sulfonyl amine. Now, if I treat this entire compound, that is a compound containing acidic hydrogen, with a base, that is NaOH for example, what would happen? OH and H would combine, giving us water. And now what we would get is nothing but a sodium salt of the corresponding aryl sulfonyl group, and this would be therefore said to be soluble in NaOH. So if a primary amine is treated with Heinsberg reagent and then treated with NaOH, it would be soluble. let's see with the secondary amine. Now, let's take a secondary amine. Let's take R2NH. Treat it with Heinsberg reagent, that is benzene sulfonyl chloride. Again, what would happen? H and Cl would combine, giving us HCl. And along with this, what you would obtain? You would obtain a compound in which benzene ring is attached to S, double bond O on both sides, also attached to NR2. Now, does this compound consist of an electron donating group? No, it consists of an electron withdrawing group. And also, does it have any acidic hydrogen? No, it does not have any acidic hydrogen. Both of them are R groups. Therefore, would it react with a base? No, it would not react with a base. And if it is not reacting with a base, would it be soluble in NaOH? No, it would be insoluble in NaOH. So this was all about the reactions of primary, secondary amine. Let's move towards the tertiary amines. Let's take R3N and treat it with benzene sulfonyl chloride. Now what would happen? Does a tertiary amine consist of an active hydrogen? No, it does not consist. All of them are R groups. So if there is no active hydrogen, would there be a reaction? No, there would not be a reaction between a tertiary amine and a benzene sulfonyl chloride. Hence, you would get a no reaction form. Now, what we can say, when primary amine was treated, you got a compound which was soluble in NaOH. When secondary was treated, you got a compound which was insoluble in NaOH. And tertiary did not react. So now, could you differentiate between primary, secondary and tertiary using Heinsberg reagent? Yes, we can do it. And therefore, this would be a very, very important reaction for distinguishing. So now, what we can say is that all the tertiary amines, which are either aliphatic or aromatic, they would be treated with acid as well as a base. But they are soluble in acid and they are insoluble into base. So this was all for this module, students. Meet you in the next module. Till then, thank you.